So what I want to do in this video is I just want to kind of give a recap of everything that is in, or a chunk of the things that are in lesson 8. So I'll look at the first one here. I have 4 parentheses 2x plus 1 parentheses x minus 3 equal to 0. So we know when we have parentheses equal to 0, we're going to set each of them individually equal to 0 and solve. But the one thing I want to look at here is the 4 that was on the outside. Now, if we set everything equal to 0, including the 4, we recognize that 4 equals 0 doesn't make any sense. However, be careful, because if it was 4x equals 0, then we would have to divide both sides by 4, and 0 would be one of our answers. So we do have to be careful. If there is an x out in front, then you do have to set that number equal to 0. If we look at our parentheses, then 2x plus 1 equals 0, we get 2x equals negative 1 after we subtract the 1 on both sides. Divide both sides by 2, and x equals 1/2 is one of our solutions. And then here we're going to add 3 to both sides, and we get x equals positive 3. So in that case, then, we're in pretty good shape, and those are our two answers. If it is not set equal to 0, well, then what we have to do is we have to start by setting it equal to 0. So x squared minus 11x, and in this case would be plus 24 after we subtract the 4 on both sides, is equal to 0. If we review factoring here, it's the first term top left, last term bottom right. We take that first number, which in this case is the imaginary 1, multiply it by the last, so 1 times 24 is 24. And then it adds to negative 11. Well, what does that? Negative 8 times negative 3 is positive 24. And negative 8 plus negative 3 is negative 11. So we have negative 8x and negative 3x. GCF the top row, you can take out an x. X times x is x squared. X times negative 8 is negative 8x. X times negative 3 is negative 3x. And then negative 3 times negative 8 is 24. So our two parentheses are x minus 8, x minus 3, and that's our factoring. But since it's equal to 0, now we have to set each parenthesis equal to 0 and solve. So we get x equals 3 when we add the 3 to both sides. We get x equals 8 when we add the 8 to both sides, and those are our two answers. The other piece we want to look at is we want to look at rational versus irrational. So really, one of the major things we need to look at is, what are our rational numbers? Well, 7, so all of our integers, fractions that don't have square roots, decimals that stop, or decimals that repeat, but also the square roots of our perfect squares, like the square root of 9, because that's really 3, the square root of 25, because that's really 5. Those are our rationals. When we look at our irrationals, we're looking at numbers like pi, but more importantly, we're looking at our square roots that are not perfect. So like square root of 2, square root of 3, square root of 20, those are all not perfect squares. So therefore, those are going to be our irrational numbers. And then you want to remember a couple rules. And really the main rule you want to look at is the sum, okay? And now it could be sum or it could be difference of a rational and an irrational is always irrational. All right. So whenever you have one of each, one R, one I, you always get an I. All right. Now don't write this as an explanation or as an answer. You're going to want to write that sentence, but that's just a little visual representation for you. Simplifying radicals. So we get to the point where we have something that looks along the lines of, so let's go square root 32. Maybe we'll do square root of 45. So remember, you want to find all the numbers that multiply to give you 32. Now remember, 1 in itself is never the option. So those are all the numbers that give us 32. You want to identify your perfect squares, so 16 and 4. But then you always want to pick the biggest perfect square, and that's always going to go on the left. So in that case, this is 16. So square root 16, square root 2. Square root of 16 is 4. Square root of 2 just stays. Now remember, if you're just simplifying, it's not a big deal. If you are solving, so in other words, we have x equals, we always want to make sure we do our plus or minus out in front. So if we look at what gives us 45, we said 1 and 45 is never the option. So 3 and 15, 9 and 5. Well, in this case, only one of them has a perfect square at all. So that gives us square root 9, square root 5, comes back together to give us 3 square root 5. Okay, and again, if you're solving, you want to make sure you put that plus minus out in front. So for example, here's a little bit of our solving. So this would be an inverse operation. We want to work to get the parenthesis by itself. So we'll add the 50 to both sides first to start. 2 parentheses x plus 5 squared equals 200. Divide by 2, divide by 2. X plus 5 squared equals 100. Square root both sides. When you square root a parenthesis, you just get what's left inside. Square root of 100, since 100 is perfect, and we are now solving, the square root of 100 is plus or minus 10. We'll subtract the 5 on both sides. Remember, if you do this, that's very bad. You do not want to just write x equals plus or minus 5 because 10 minus 5 is 5. What you do is you take the number you move to the other side, that goes out in front, plus minus goes in the middle, and then that 10 would go at the end. Since there are no square roots left, you want to actually do this. So it's going to be negative 5 plus 10 is going to give us one answer, and then negative 5 minus 10 is going to give us another answer. So negative 5 plus 10 is 5, negative 5 minus 10 is negative 15, and then those would be our two answers. Here, if we look at x plus 4 squared minus 20 equals 0, well, it's basically the same process that we just did, except when we get to the square root part, it's going to change a little bit. So we add the 20 to both sides, take the square root. Same deal with the parenthesis, except 20 is not perfect, so we have to split it. 20 splits into square root 4, square root 5, comes back together to give us, and again we're solving, so now it's going to be plus or minus 2 square root 5. We'll subtract the 4 on both sides. Now this definitely cannot combine nicely because of the square root. So this is what is known as simplest radical form. All right, so if you get x equals negative 4 plus 2 square root 5, that's simplest radical form, and you could stop right there. If they tell you to round, you would have to do negative 4 plus 2 radical 5 and negative 4 minus 2 radical 5, kind of like we did in the last example. The only difference is you're going to need your calculator for this one. And if we round here to the nearest tenth, we would get 0.5. And then if we do the same thing again here, but with a minus sign, negative 4, let's clear the whole thing. So negative 4 minus 2 radical 5, that would give us negative 8.5. And then those would be your two answers if you were told to round. And in this case, we went to the nearest tenth. Okay, so two different answers, simplest radical form, and then the rounding one. Now if we want to do the process of completing the square for solving. So for example, x squared minus 8x plus 3 equals 0. Okay, we know this isn't factorable because there's going to be nothing that multiplies to 3 and adds to negative 8. So what we do is we put in our lines. So after the 8x goes plus a line, and that whole beginning goes in parentheses, then it's our constant, and it's always minus a line in the second piece. So you take the first, or the middle number, which is the negative 8, and divide it by 2 to get negative 4. Square it, and that gives you 16. So on the first line, you get a positive 16, and then the last line, negative 16. So this parenthesis here always factors all right? And we could take the time to get our two parentheses that it factors into, but the whole point of this is that when we would factor it, we'd get the same exact parenthesis twice. In this case, we get x minus 4, which really is x minus 4 squared. But we don't want to take the time to do that. So if you pay attention to your dividing piece here, whatever number you get after dividing by 2 is always the number that goes in the parentheses. And then on the outside, 3 minus 16 is negative 13. So then we'll just solve the same way we did in the previous problems. X minus 4 squared equals 13 when we add it to both sides. Square root. 13 is not perfect. 13 does not split, so we just get plus or minus square root 13. We'd add the 4 to both sides, and you get x equals 4 plus or minus square root 13. All right, and that would be a completing the square with something that we're going to solve. Now the quadratic formula. So I picked a little bit of a challenging one here. 4x squared plus 5x plus 3 equals 2x squared minus 3x. So we never want to do anything with any of these until it is set equal to 0. So I'm going to subtract the 2x squared and add the 3x on both sides. That's going to give me 2x squared plus 8x plus 3 equals 0. Now this could be a factorable situation, but if you look, if you multiply 2 by 3, that would be 6, and there's nothing that's going to multiply to 6 and add to 8. So this is probably not a factoring situation. I'm going to write the quadratic formula over here on the side. So you get x equals negative b, which remember is just the opposite sign of b, plus or minus big square root b squared minus 4ac all over 2a. Now, how do you tell what each of those is? Well, a is always the number in front of x squared. In this case, that's 2. B is always the number in front of x, which in this case is 8. And c is the constant, which in this case is 3. Now, all of these are positives, but you need to make sure that if any of them are minus signs, that you include the negative for each of those. So x equals negative b. So the opposite sign of positive 8 is negative 8. Plus or minus big square root 8 squared minus 4 times 2 times 3, right? A times c, all over 2a, which is 2 times 2. So x equals everything that's underneath the square root except for the square root goes into your calculator at the same time. So we're 8 squared minus 4 times 2 times 3 gives us 40. So x equals negative 8 plus or minus the square root of 40 over, and 2 times 2 is 4. Now, the biggest mistake that people make is they start to divide the negative 8 and the 4. Not yet. The first thing we have to do is deal with the 40. 40 is not perfect, but 40 does split to the square root of 4 and the square root of 10, which gives us 2 square root 10. So we're going to replace x equals negative 8 plus or minus. Instead of square root 40, we will be 2 square root 10 over 4. And now you are at the place where you are allowed to simplify if you can. So you look at the numbers that are outside, negative 8, 2, and 4. You can divide all of them by 2. So if you divide negative 8 by 2, you get negative 4. 2 divided by 2 is 1. And 4 divided by 2 is 2. So x equals negative 4 plus or minus. You could put 1 radical 10, but it's the same as radical 10 over 2. And that is going to be your answer in simplest radical form. Again, if you were asked to round, then you would just split it and go from there. You need to keep the 2 in the denominator. If the denominator turns into a 1 after simplifying, then you are allowed to leave it out. But there's our quadratic formula. And the last thing real quick is just the number of solutions that something has. If, when you're doing completing the square or you're doing quadratic formula, if your square root is a positive number, that means you have 2 solutions, all right? And that could be any positive number, 1, 2, 3, a million, doesn't matter. If you get the square root of 0, that means you have 1 solution, okay? And then if you ever get the square root of a negative number in this case, you want to stop what you're doing and you just want to write that there is no solution to that problem. So at any point during any of these, if you get a negative underneath the square root, that is going to be a no solution. Any positive is 2 solutions, and any 0 is 1 solution. And that's just kind of a quick recap of Unit 8.